Okay, so group theory. A group is a set G together with a binary operation, represented here by the generic binary operator, which satisfies 1. That this operation is associative, 2. That there exists an element E in G such that E operator G equals G operator E equals G for all G in G, and 3. That for all G in G, there exists G inverse in G such that G inverse binary operator G equals G binary operator G inverse equals E. So this is associativity, which is covered right here. This is the definition of an identity element, E in this case being the identity. So, for example, 1 in multiplication is the identity. If we multiply 1 by any number, we get back that number times 1, which is the same as that number. 1 times 4 equals 4 times 1 equals 4. And that works for all G in the group, so for all elements of the group. So, for example, the addition or the multiplication of the natural numbers would qualify in this way. Last but not least, we have that number 3, for all G in G, there exists G inverse in G such that G inverse binary operator G equals G binary operator G inverse equals E. So this defines an inverse whereby the number multiplied by itself, whereby the number binary operator itself results in the identity element. Again, this identity element depends on the particular group that you're in. So if you're dealing with multiplication, you're dealing with 1, which means that your numbers have to have some sort of multiplicative relationship that ends up in 1. Whereas in addition, you need some other operation that results in 0. So, for example, you have to either subtract some number of numbers somehow, perhaps by the addition of a negative number, or you have to find some other way of reaching the number, which is possible, and we're going to come across some good examples soon. Associativity. So, associativity is very straightforward. These are operations here. It's multiplication as an example, but this works, obviously, this applies for all groups, so this means this works for all group binary operations. So A, B, C, our B is bracketed, which means we do it first, nominally speaking. And here our AB is bracketed. If this holds for all the elements in the set, then your set is associative under whatever operation you're performing. So, for example, if A equals 2, B equals 3, and C equals 4, B times C equals 12, and A times B equals 6, A, B, C equals A12. A is still 2, so 2 times 12 equals 24. And then over here, A times B equals 6, right? A, B, C equals 6C. C again is equal to 4, so 6 times 4 is 24. And we see that both of our guys give us the exact same answer here, which is very useful. So, that indicates associativity to us very clearly. The multiplication of integers is associative, as is a number of different operations. And any group that we're going to be dealing with, if it is a group, such as the braid group, then that means it has to be associative. In braids, we can demonstrate A, B, C equals A, B, C in the following way. If here we have free braids, and this is our ABC setup. And then what follows here is our ABC setup. It should be clear that these are equivalent. Sorry, just double checking my crossings. So that's that section, that's that first cross, that's that second cross, and then whoop, down. My mistake. Got carried away. So we can double check this quickly. We have a crossing over here, over, under. We have a crossing over here, under, and straight, under, and straight. And then same deal over here. We have a crossing over here coming under, going over, and into the next crossing. So these two guys are good. And this here is A, B, C. So this gives us quality number 1, which is associativity. We have associativity on braids. In the case of the second quantity here, there has to exist an identity element that follows these particular rules. For braids, this would be the identity element in this particular orientation, and we can see quite clearly if we combine this with any other element, then we end up with this. So we're looking for E dot G. This is our E dot G, which equals G dot, should have a dot down here too, E, which all equals 2. G. Nice and straightforward. So from this, clearly we have our second quality here all sorted out, which leaves us, and in less space than I'd expected to do, but it's simply this, and it'll be this on any number of braids, so that qualifies that, or of course, some hideous creation. The last quality we're looking for is, of course, the inverse. The inverse we've well practiced and is very straightforward. To take, any braid really. This, for example, the inverse in braids is just the mirror. Like so. And if we connect these two braids together, then the product is the identity on however many strands we're dealing with. Which here's for. So that gives us our third operation. Right. We have all 3 properties of a group, which means this successfully defines a group.